Welcome to this video in the Mathistry unit. This is 2.10, and in today's video we're going to be covering scientific measurement and how to read instruments and measuring tools to the proper number of significant figures, which I have to tell you is an essential skill in our chemistry class, or really any lab that you might find yourself working in the future. So to effectively take in what I am teaching you today, make sure you have your chemistry notebook and you are actively taking notes in it. You are also going to need your plan sheet to practice the skills that you are being taught. So without any further ado, let's get going. When we think of science, most science is driven by experiments, and in all those experiments you wind up generating data. There are two types of data out there. There is quantitative data and there is qualitative data. Let's break these down. When you got quantitative data, they use numbers to describe what you are looking at. And how are those numbers arrived at? Well, usually through measurement with a measurement tool. And we'll get into a little bit more with that later. They tend to be numerical in nature. You're putting digits down. And often, if you use the measuring tool correctly, they are exact. Quite different than what we see on the right-hand side of the screen here, which are qualitative data. And qualitative data tends to be descriptive, lacking numbers. So when we say something is hot, something is large, something is blue, that is qualitative data. To illustrate these two examples, I'm going to throw a couple things at you here. Really quick, how many jelly beans do you see here? Well, if you pause the video and you counted them, you probably should have gotten 11, and I myself got 11 too. We agreed. How about this? How many blue markers are there in this bunch? Well, this one may not be so easy because why? There are shades of blue. What does blue really mean? And essentially, when you're looking at these two things, we agreed that there was 11 jelly beans that were here. But in terms of the blue markers, it looks like to me there might be 5. Maybe there's only 4. Maybe something that you thought was blue actually was green to another person. And so what we see is that if you are a scientist, you are always going to prefer quantitative data because there is no personal bias. A 5 is a 5, a 2 is a 2, a 4 is a 4. When we say something is hot, well, hot for one person may not be hot for somebody else. I love spicy food. My kids, well, they didn't always love it, and what was not hot for me was super hot for them. So anyway, getting back to measurement, all measurements are always going to be subjected to limitations and errors, such as method errors and instrument errors, and of course, human fallibility, which I'm going to make a point here. Never say human error was your error source, because it's only an error once, and then you fix what you did and move on. But anyway, I digress. In the end, when we're generating data, scientists want their results to be as accurate and as precise as possible. With that in mind, it is all about being able to measure properly to actually get data that is usable and is scientifically sound. So most people think they can measure, but welcome to chemistry. The rules of measurement have changed slightly from what you guys knew. So get ready. I'm going to teach you guys how to measure. So let's consider these volumes. We got a graduated cylinder over here to the right, and if we read the volume that's inside it correctly to the meniscus, we see we have approximately 6 milliliters. So 3 different students record the same volume here, and one records it as 6, one records it as 6.0, and one decides to be a serious scientist and record it as 6.00 to the hundredths place. Well, in the end, I can tell you this: the more digits that we include in a measurement, the more precise our measurement is. And more precision means better measurements means better data, and when our data is good, we have a better experiment. But the truth is, when you are using an instrument in the science lab, you can't always just go willy-nilly and put down whatever number of digits after the decimal point that you want. So here is the first rule of scientific measurement. Essentially, when recording a measurement, we have to include all of the known digits, and known digits are things that we are sure of based on the measuring tool. And because we are fantastic scientists, we are allowed a final estimated digit. Let's break down what that means looking at these two rulers here measuring the same red paperclip. So the first thing we're going to notice is that this ruler that's here and this ruler that's here are different. Yes, they are both centimeter rulers, but you will notice that the bottom ruler has 10 graduations or increments or tick marks between the numbers, and the top one does not. So if we were to measure this paperclip using the top ruler, we are going to record in the measurement all the known digits, which means everything we're sure of, plus our estimate. And this is really called measuring to the proper number of significant figures. Let's apply it. We know right now that this paperclip is more than 2, but less than 3. So I am sure of the fact that it's 2 centimeters. Now I am going to estimate in between here, where does this end of the paperclip fall? And I will notice that it falls about 1/3 of the way through. So I can't say 0.33 because I can't estimate out that far to the hundredths, but I can usually estimate 1/10 beyond what I am sure of. So in this case, I'm going to say it is 2.3 centimeters. This ruler here has more precision to it because you guys can see these graduations that are here. So I know that this paperclip is, what am I sure of? Beyond 2 and less than 3. And now because we have these graduations that we see, that we know it's beyond 2.1, 2.2, 2.3, but it is not beyond 2.4. So it's falling somewhere in between 0.3 and 0.4. So right now I am sure of 2.3 something, and it's up to you as a scientist to make an estimate. In this case, I'm going to say it is 2.33 centimeters. That is the estimate there. And it could be any number. It could be a 5, could be a 2, could be a 4, as long as the number is reasonable. So now that we've learned this, let's try an example. Here's a graduated cylinder, and what I want you to do is read the volume at the meniscus to the proper number of significant figures using the rules of scientific measurement. Everything you're sure of plus one place beyond. So pause the video now and then unpause when you've got an answer. All right, if you did this correctly, we should have gotten 43.1 milliliters. We were sure that the meniscus was above 40, 41, 42, 43, but below 44, which is here, so we could say it was 43. Now we are going one place beyond the ones, which is the tenths place. We're reading this to the tenths. I'm estimating it to be 0.1. So 43.1 is your answer. You guys try this one. Here is a thermometer. Tell me what the Celsius temperature of this thermometer is. Pause the video now and then unpause when you got an answer. All right, if you did this correctly, you should have gotten 26.5 degrees Celsius. We were sure that the temperature, if here's 20, it was 21, 22, 23, 24, 25, 26. So it was more than 26, but less than 27. So that meant that I was sure of these two digits here. Now I'm going to estimate. I think it's something in the middle. I'm going to estimate the 5, and that gives me 26.5 degrees. Not too bad. Let's try one more. Here is a ruler. And what I want you to do is read the ruler and measure to the proper number of significant figures using the rules of measurement. Pause the video now and then unpause when you got an answer. All right, if you did this correctly, we get a line segment that is 8.53 centimeters long. Each one of these increments here is a millimeter, and so I was sure that it was, let me see, 8, 8.1, 2, 0.3, 0.4, 0.5, a little bit beyond 0.5, but not beyond 0.6, so it falls somewhere in the middle, so I was sure of these two here, and that 3 there is my estimate. So if you had any questions on this lesson, make sure that you have them with you and bring them to the burning questions segment tomorrow morning in class. We can address anything that you found difficult or just generally did not make sense. So that's pretty much it for me. It's been a pleasure teaching you all about how to measure to the proper number of significant figures. We'll see you in the next video. Peace out.
That's all, folks.